Okay, gang, so there's only a couple weeks left of school. I only have a couple lessons left. And so I'm going to get as much integrals in here as possible, starting with the fundamental theorem of calculus. This is the actual formula, and we're going to be using this in a minute. I just wanted you to look at it because I want you to see it looks kind of complicated, but it really is very easy. We have been finding definite integrals, we've been finding indefinite integrals, which is really the area under the curve, and we've been using shapes. We've been using rectangles and trapezoids and circles and triangles. We've been using all kinds of shapes to find the area under the curve. But when you have a funky curve, there is a process called the fundamental theorem of calculus that we are going to use. So let me go ahead and get started. First, we need to remember how to find the indefinite integral, and that means the antiderivative. That's what this means. Indefinite integrals, and hopefully you recognize that on your quiz. Indefinite integrals are finding the antiderivative. There's no numbers on the little integral symbol. And so what we are going to be doing, and just to refresh you, it is x to the n plus 1 over n plus 1. That's all it is. Get your x by itself, then you can add 1 to the exponent and then put that underneath. So for each of these terms in this particular first problem, just keep the 2, then it's going to be x to the 4th over 4. When it's a single constant, you just put x on it, 1x. Now I'm going to simplify this to 1/2 x to the 4th plus x and plus c. Because if it is indefinite, we don't know what this is a family of functions. Okay, so here again, and the dx, just to remind you, the dx is to remind you that this is a derivative, and we are finding the original function that they took the derivative of. So that's what the integral does. Okay, so for this one, I'm going to go ahead and do this fraction problem here. X to the 1/2 becomes x to the 3/2 over 3/2 plus 3x squared over 2, because it was originally a 1, I added 1, and then I put it over the added one. And then minus 4x, and then I'm going to simplify it. When you simplify, you flip any fractions on the denominator, so it's going to become 2/3 x to the 3/2 plus 3, and you can put 3/2 however you want to write that, and minus 4x plus c. I'm going to skip 3 and I'm going to jump down to 4. Anything I skip is going to be in the notes that I send to you. This one was like one that was in like the very first problem from your quiz. You guys forget that this is actually 1/8, so I'm going to rewrite this as 1/8 x to the negative 2. The 1/8 is a coefficient, and then I can do x to the negative 2. So I'm going to leave it, when I fix it, when I take the integral, I'm going to do 1/8 and then x to the negative 1 over negative 1. Treat them like two separate things. So a lot of you were trying to group it together, and so I'm just showing you again what this really happened here. And then when I fix that, it's going to be 1 over 8 still, and then 8x to the negative 1 goes to the bottom, and the negative 1 makes it negative, plus c. Okay, so here's the actual process. The reason I did refresh you on those antiderivatives is because we are going to be using that. That's the first step in the process, is you find the antiderivative. Now I want you to notice, this is the derivative, this is the antiderivative. So little f is in the integral, big F is the antiderivative after you have applied the integral. Notice we have Definite integrals, we're going from A to B. So we are going to have an actual shape that we are finding the area under the integral. We're going to get an answer for that area. For antiderivatives, we just got a family of functions that described it. Now we're getting the actual number. And so once you get that antiderivative, capital F, function, you're going to plug in B, and you're going to plug in A, and you're going to subtract. And that's it. That's all there is to this. It's not hard at all. Notice we're not going to use the constant plus C anymore because it's going to cancel out when you subtract anyway. It's the same number. It doesn't change anyway. So we're not going to use the plus C anymore. Okay. Now, here's some examples. First, step 1, take the antiderivative of x to the third. Well, that would be x to the fourth over 4. Now, and they use a little funky bracket, I just use a line, from 1 to 3. So I'm showing you that I'm going to apply the interval of 1 to 3. I'm going to plug those in for x. I'm going to start with the bigger one, the second one. And so that would be 3 to the fourth over 4. Now I'm going to do the second one, 1 to the fourth over 4. So I'm subtracting, no big deal. This is 81 over 4 minus 1 over 4 equals 80 over 4, which equals 20. That's the answer. So the area under this x to the third curve between the interval of 1 to 3 is 20 units, whatever the units are. I'm going to do another one. Take the antiderivative. Antiderivative of x squared is x to the third over 3. Antiderivative of minus 3 is minus 3x. I am going to go from 1 to 2. I'm going to plug in 2 to the x, both of those x's. So if my first section is 2 to the third over 3 minus 3 times 2. So now I have done the B portion. Now I'm going to do the A portion. When I do the A portion, I am going to subtract the entire thing. Very important to subtract the entire thing. I have an expression now. It's not just a single term like it was in the last one. It's now an expression of 1 to the third over 3 minus 3 times 1. Now when you figure this out, if you happen to figure out the first portion first, that turns out to be negative 10/3 minus, and the inside of this parentheses here is negative 8/3, or you can put it all in your calculator at once. Some people kind of get tripped up on that sometimes. Make sure you use parentheses as needed, but the final answer for this is negative 2/3. Decimals are also fine. Okay, here's a couple more examples. So for this one, I'm going to fix this first. So it goes from 1 to 4, and that's 3x to the 1/2. Now I'm going to take the antiderivative, keep the 3, and that'll be x to the 3/2 over 3/2. But I need to fix that so it'll be a little easier to work with. I'm going to show you the steps. Keep the 3, flip that to 2/3, x to the 3/2. But that's all there is to it. I'm going to go ahead and finish simplifying that one more time. It ends up being 2x to the 3/2. And now I can go from 1 to 4. And I chose this interval from 1 to 4 because it's going to work out nicely for that square root portion. So I'm going to put 4 in there, 2 times 4 to the 3/2 minus 2 times 1 to the 3/2. 2 times 4 to the 3/2 turns out to be 16. 2 times 1 to the 3/2 turns out to be 2. So your final answer is 14. Now number 4, we have some trig. We haven't done a whole lot of trig. If I give you a trig problem, I will make sure that I have a little table for you to refer to so you can see what the antiderivative is. The derivative of tangent is secant squared, So the antiderivative of secant squared is tangent. So this turns out to be tangent of x from 0 to pi over 4. Notice this is in radians. Keep this so you guys remember this stuff. You can either use radians or you can change it to degrees, which is 45 degrees. But if you're going to use the pi over 4, you got to be in the radian mode in your calculator, just to remind you. So you're going to put tangent of pi over 4, or 45, minus the tangent of 0. This turns out to be 1 minus 0, which turns out to be 1. So it's not as hard as it seems, because it's like, oh, pi, I forgot about secant and pi and all that stuff. It's really not that bad. Like I said, I'm going to give you tables as needed. Now I'm going to show you how to do it in your calculator. So here we are. So the first 4 problems are like the 6 or 7 problems you're going to have for homework. And then this one right here that I'm going to do, you get to use your calculator on the second page, where you're going to be given some graphs, just like this graph, so that you can see what you're actually doing. We are finding the area under this curve. But I want you to set up an integral so that you can put it in your calculator. So you're given a function, 1 over x. And so I'm going to go ahead and set up my integral, and it's from 1 to 3. So from 1 to 3, there's the function, dx. Now in your calculators, it should be under math. You should be able to find math and integral. On my TI-83, so on my TI-83, it is math, and it is number 9, is the function integral. And to put in, so when you push that in, you're gonna, so if you have an old calculator like mine, the other calculators you should be able to just fill in these pieces. The 1, the 3, the 1 over x, and the dx. You should be able to put all that in. It will not work if you don't have the dx, I'm pretty sure. But for these, so on your screen, you're going to see FNINT parentheses. Then you are going to put the function, 1 divided by x, comma. For computer programs, they like to have the variable defined, so then you have to put x. So it's the function, then it's the variable, then it's the interval from 1 to 3, and that's all there is to it. And when you put this in your calculator, you should get 1.098, and it keeps going. So this is all you have to do. So your second half of your homework, you're going to have graphs. I want you to write the interval for the graph, and then you can plug it into your calculator. If you need more help with this, please let me know. We will be meeting on Thursday, so I'm going to make sure you guys understand this portion, because you're going to need to know how to put it in your calculator to do the next section. And then those will be the last couple of sections that we learn for the year.